A vast and infinite universe has always held secrets beyond our wildest imaginations, stretching the boundaries of what we perceive as possible and humbling our understanding of space, time, and existence. The cosmos, with its endless expanse and immeasurable scale, has intrigued philosophers, astronomers, and dreamers for millennia. And often, these deep space enigmas prevent the sharing of information crucial to the advancement of science and our understanding of fundamental cosmic truths. Despite our progress, there is still so much we don't know. Discovery, in its truest form, often begins not with answers, but with questions that defy our current knowledge, provoke wonder, and sometimes even disrupt long-standing scientific theories. Recently, the most advanced telescopes, operating at the cutting edge of technology, have detected a phenomenon that defies all known logic. A cosmic mystery so profound it has left scientists across the world baffled and grasping for explanations. Findings from the James Webb Space Telescope, humanity's most powerful and sophisticated space observatory to date, have sparked new discussions and raised questions that challenge the foundational assumptions of modern cosmology, including calling into question the well-established Big Bang theory itself. Joel Rogan, a prominent science communicator and commentator, takes a deeper look at this telescope's latest discovery, which has revealed the shocking disappearance of approximately 900 trillion stars, an occurrence that no current model can fully explain. The $10 billion James Webb Space Telescope, JWST, launched and operational in space for over 2 years now, has already provided a treasure trove of invaluable astronomical data. But its latest findings may prove to be the most revolutionary. Even in this short operational time frame, the data gathered has proven that the telescope's investment was not only worthwhile, but may turn out to be one of the most consequential scientific endeavors in human history. Far surpassing its predecessor, the Hubble Space Telescope, Webb provides unprecedented, high-resolution views of deep space and looks further back in time than any previous mission, observing the faint infrared light from the earliest galaxies formed after the universe's birth. In July 2022, shortly after its commissioning, the James Webb Telescope began exploring extremely long wavelengths of light emanating from distant galaxies, wavelengths invisible to the human eye and inaccessible to earlier telescopes. These wavelengths, part of what scientists call the redshifted ultraviolet spectrum, are key to understanding the earliest and most remote regions of the cosmos. Redshift occurs when light from distant galaxies is stretched due to the expansion of the universe, causing it to shift toward the red end of the spectrum. What Webb has detected in these deep regions has exceeded expectations, revealing astonishing details that had never been seen before: structures, galaxies, and anomalies that were completely beyond the reach of Hubble and other space-based instruments. One of the most disturbing revelations, however, is the unexplained disappearance of 900 trillion stars in the vacuum of space, stars that were once visible, documented, and expected to remain in observation, but now appear to be missing entirely. This startling finding has raised deeply unsettling questions about how such an astronomical number of stars could have disappeared without leaving a trace. Each new piece of data collected adds to the growing air of mystery and concern surrounding the phenomenon. In a surprising and highly unusual observation, the James Webb Telescope has recorded the absence of light from entire stellar regions, where trillions of stars were previously detected. This absence is not due to a malfunction or temporary glitch. It's a consistent and repeated measurement across multiple sessions and wavelengths. The question now reverberating across scientific institutions and observatories is, where have these stars gone? There are currently two main theories that attempt to explain this phenomenon. The first, more conservative theory suggests that the stars may still be present, but for some reason their visibility has been obscured or diminished. This could be due to a significant drop in luminosity. Perhaps the stars have entered a late stage in their life cycles, radiating at wavelengths that are no longer detectable with current instruments. Another explanation might be the presence of thick interstellar dust clouds or dark matter structures that have temporarily obscured the view of these stars. Alternatively, these stars could have collapsed into black holes without the usual supernova explosion that typically accompanies such a transition, hiding them from all known forms of detection. The second theory, far more alarming and difficult to reconcile with existing cosmological models, posits that the universe may be undergoing a previously unknown and unstoppable process of disappearance, perhaps even a form of cosmic decay or dimensional collapse that we cannot currently understand or prevent. This concept, while speculative, introduces the unsettling possibility that we are witnessing an aspect of universal behavior not accounted for in the standard model of cosmology. For nearly a century, the dominant theory in astrophysics has been that the universe is expanding. Since the early 20th century, following Edwin Hubble's observations of galaxy redshifts, scientists have agreed that galaxies appear to be moving away from one another at increasing speeds, a phenomenon attributed not to the motion of the galaxies themselves, but to the expansion of space itself. This interpretation became the cornerstone of the Big Bang theory, which states that the universe began from a singularity and has been expanding ever since. As space expands, the distance between galaxies grows, causing the light from those galaxies to stretch and redshift. About 20 years ago, astronomers discovered that this expansion is not merely ongoing, but actually accelerating. The galaxies that are furthest from us appear to be moving away at increasingly faster speeds. This acceleration is believed to be driven by dark energy, a mysterious and invisible force that constitutes about 68% of the universe's total energy content. When we observe stars whose light has traveled for 100 years to reach us, we are effectively looking at events that occurred 100 light-years away and 100 years ago. However, when we examine galaxies whose light has traveled for 100 million years or more, those galaxies are, in reality, even farther away than their light travel time would suggest. That's because while their light was en route to Earth, the space between us and those galaxies continued to expand. This expanding universe means that the farther away a galaxy is, the faster it appears to be receding from us. On very large cosmic scales, those that involve entire galactic superclusters, the fabric of the universe plays a dominant role in shaping how we interpret distance and time. This phenomenon manifests itself as redshift, and the greater the redshift, the faster the object is moving away. If the universe were not expanding, the light we receive from distant objects would retain its original wavelength. But due to the continuous stretching of space, the wavelengths are elongated, resulting in a redshifted signal. The most significant redshifts we've observed in the farthest galaxies offer some of the strongest evidence supporting universal expansion. However, our task as scientists and observers goes far beyond merely confirming this expansion. We use the information contained within the light of these distant sources to reconstruct the timeline of the universe, to chart its composition, and to predict its ultimate fate. As light from a cosmic source travels through expanding space, it undergoes stretching, and the resulting redshift grows more pronounced the longer that light has been traveling. By measuring this redshift at various distances and comparing the known intrinsic brightness of the sources to what is observed, astronomers can build a detailed history of the universe's expansion. Furthermore, the rate at which the universe expands is influenced by the different forms of matter and energy that fill it. Currently, it is believed that approximately 68% of the universe consists of dark energy, which behaves similarly to a cosmological constant. About 27% is dark matter, an unseen form of matter that exerts gravitational influence, but doesn't emit or absorb light. The remaining 5% comprises regular matter, protons, neutrons, electrons, neutrinos, and photons, everything we can directly observe or detect. Other hypothetical entities, such as cosmic strings or topological defects, have not been observed. Knowing these cosmic ingredients allows physicists to apply Einstein's theory of general relativity on the grandest scales and predict the future of the universe. What emerges is a sobering conclusion. Because dark energy dominates, galaxies that are not gravitationally bound to our own will continue to drift away at ever-increasing speeds. Eventually, the expansion will reach such a rate that any light emitted from those galaxies will never be able to reach us. Even though some galaxies may be only 18 billion light-years away, the expansion of the universe ensures that the photons they emit now will forever be out of reach. Our observable universe, currently around 46 billion light-years in radius, is actually shrinking in terms of what we will be able to observe in the future. If we assume that the distribution of galaxies is roughly uniform across space, then only about 6% of all the galaxies currently within our observable universe are accessible to us in principle. This means that 94% are already receding beyond our cosmic horizon, unreachable even by light. Furthermore, it is estimated that between 20,000 and 60,000 stars transition from reachable to unreachable every single second. While the light emitted by these stars before they cross that threshold will still eventually reach us, the light they emit now and in the future will not. This revelation is not only unsettling, it is a stark reminder of the impermanence of our cosmic connection to the broader universe. From a more optimistic viewpoint, this knowledge underscores the urgency of space exploration. If humanity ever hopes to explore regions beyond our local group of galaxies, which includes the Milky Way, Andromeda, and several smaller satellites, then every second that passes is a lost opportunity. The cosmic clock is ticking. Of the estimated 2 trillion galaxies in the observable universe, only a fraction will remain within our reach unless we develop revolutionary methods of travel that allow us to bridge these expanding distances. As the universe continues to stretch and the acceleration shows no signs of slowing down, humanity faces the possibility of becoming eternally confined to a shrinking observable bubble of space. Unless we discover new physics that can counteract or manipulate the effects of dark energy, we may eventually become isolated from all but the most nearby galaxies. Our ability to send or receive signals across the vast cosmos will fade, and the richness of the universe will become hidden behind an unreachable veil. The expansion of space is relentless, and our current gravitational technology is not sufficient to defy it. The universe will continue to grow colder, emptier, and more isolated. While this reality can be disheartening, it also serves as a powerful motivator, reminding us to cherish the fleeting window we have and to explore, discover, and understand as much as we can while we still can. If you found this video insightful, please consider liking and subscribing. It helps us continue to create high-quality content and bring you the latest from the frontiers of space science and cosmic discovery.